Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0328, indicates a high-voltage issue in the knock sensor circuit of the Honda Civic models produced between 2011 and 2015. The knock sensor is a critical component responsible for detecting engine knock or detonation, an abnormal combustion event. It is located near the engine block and works by monitoring vibrations associated with knocking. When the sensor detects such vibrations, it sends a signal to the engine control module, ECM, adjusting ignition timing to prevent engine damage. A high voltage in this circuit can cause incorrect signals, leading to poor performance or engine damage if not resolved. Proper troubleshooting is essential to identify the cause of this DTC and ensure optimal vehicle operation. The knock sensor plays a vital role in a vehicle's engine management by detecting knock or pre-ignition events and sending corresponding signals to the engine control module, ECM. Located typically on the engine block, it utilizes piezoelectric technology to sense vibrations. The sensor converts these vibrations into electrical signals, which inform the ECM about the engine's combustion state. In the event of a high voltage reading on the knock sensor circuit, the ECM may misinterpret signals, leading to possible performance issues or engine damage. This diagnosis requires careful observations of not just the knock sensor, but also the wiring and connections to the ECM to pinpoint the fault effectively. Several potential causes can lead to the triggering of DTC P0328. Firstly, a faulty knock sensor could produce erratic signals due to internal damage or malfunction, resulting in high voltage readings. Secondly, wiring issues such as frayed, corroded, or disconnected wires can disrupt the communication between the knock sensor and the ECM, causing erroneous voltage levels. It's also essential to consider the possibility of an ECM fault, where the module fails to process the information correctly or misreads the sensor data, leading to high voltage being reported. Each of these causes must be methodically checked during the troubleshooting process to identify the specific issue affecting the knock sensor circuit. The symptoms associated with DTC P0328 can severely affect vehicle performance. Drivers may experience rough engine operation due to improper ignition timing adjustments made by the ECM in response to faulty knock sensor readings. This can lead to decreased engine performance, affecting acceleration and overall responsiveness. Additionally, the check engine light will illuminate on the dashboard as a warning sign that the system has detected an issue. It's important to note that while these symptoms are indicative of a knock sensor problem, they may also be associated with other engine issues, underscoring the necessity for thorough diagnostic testing using the Honda Diagnostic System, HDS. The first step in troubleshooting DTC P0328 involves verifying the issue at hand. Begin by turning the ignition switch to the on position, which powers up the vehicle's electrical systems without starting the engine. Next, clear the existing DTC using the Honda Diagnostic System, HDS. This process effectively resets the system and allows for new diagnostic data to be captured. After clearing, turn the ignition switch to lock and then back to the on position again. Finally, check for any pending or confirmed DTCs on the HDS. If P0328 is indicated, it confirms a duplicated failure, progressing to the next step. Conversely, if no issues appear, this suggests an intermittent failure, warranting a check for poor connections or loose terminals. To determine the possible failure area related to the knock sensor, the next step requires disconnecting the knock sensor's 2P connector. After ensuring the ignition switch is turned to lock, proceed to disconnecting the specified connector. With the connector disconnected, turn the ignition switch back to the on position again. At this point, you will measure the voltage between the two test points specified: knock sensor 2P connector number 1, the black wire, and number 1, 2, the white wire. The expectation here is to find a voltage reading of approximately 5.0 volts. If this level is present, it suggests the wiring is intact, indicating a replacement for the knock sensor is necessary. If not, further investigation is warranted in the next step. In this step, you will check the voltage between two significant test points to diagnose potential failure areas specifically within the knock and KSGND lines. Keeping the ignition switch at the on position and with the knock sensor 2P connector still disconnected, focus on measuring the voltage between test point 2, the white wire of the knock sensor 2P connector, and body ground. This will help determine whether a reading of approximately 5.0 volts is present, indicating that the knock signal circuit is functioning correctly. Should the voltage be acceptable, it directs the troubleshooting process further. Otherwise, it will lead to checking the next step for potential wiring issues or faults. Now, an open wire check is essential for assessing the KSGND lines to ensure proper continuity. With the ignition switch turned to lock, jump the SCS line using the Honda Diagnostic System, HDS, to secure the circuit. Once set, disconnect the ECM connector C. It's necessary to connect terminals A and B. A jumper wire should connect knock sensor 2P connector, number 1, the black wire, to body ground. This allows for a continuity check between the designated test points. At this stage, check for continuity between ECM connector C, 49P, number 48, green wire, and body ground. If continuity exists, it confirms that the KSGND wire is functioning correctly. If not, you will need to repair the open circuit in the KSGND wire between the ECM and the knock sensor. The concluding wiring check addresses the knock and KS lines, ensuring that both communicate correctly. Similar to the prior step, turn the ignition switch to lock and again jump the SCS line with the HDS. Once this setup is complete, disconnect the ECM connector C once more. With terminals A and B connected, where terminal A is the knock sensor 2P connector number 2, white wire, and terminal B is connected to body ground, the next action is to check for continuity. It's crucial to measure between ECM connector C, 49P, number 17, red wire, and body ground. If continuity exists, it indicates the wires are in good condition. If not, an open circuit in the knock KS wire is detected, requiring repairs between the ECM and the knock sensor for restoring functionality. Once all repairs are complete, it's imperative to conduct a final verification of the repair steps taken. Start by ensuring all connectors, including those of the knock sensor and ECM, they're securely reconnected. Turn the ignition switch to the lock position to ensure everything is ready. After that, reset the ECM using the Honda Diagnostic System, HDS, to clear any historical fault codes and prepare the system for a fresh start. After resetting, turn the ignition switch back to the on position and check for any pending or confirmed DTCs again. If P0328 is still indicated, there may be problematic connections or loose terminals that need to be checked again. If no DTCs appear, the troubleshooting process is successfully completed. Preventive maintenance is crucial to avoid recurring issues related to DTC P0328. Regular inspections of connectors, especially those linked to the knock sensor and ECM, can prevent moisture intrusion, corrosion, or loose connections that could lead to faults. Moreover, keeping a close eye on engine performance and addressing any early symptoms of abnormal operation can help identify trouble before it escalates. It's also advisable to stay updated on software versions for the ECM, as outdated software can introduce bugs or issues impacting sensor performance. Regular maintenance checks can save time, money, and the hassle of unexpected repairs, all while ensuring the longevity and reliability of the vehicle. In summary, DTC P0328 indicates a high voltage condition in the NOx sensor circuit, which can compromise engine performance. By following the structured troubleshooting steps to verify the problem, check voltage readings, and assess wiring, you can accurately identify and address the fault. It is of utmost importance to complete the final repair verification to ensure all components are functioning before concluding the service. Preventive maintenance practices, including inspections and updates, cannot be overstated. They play a vital role in maintaining vehicle reliability and performance. Staying proactive in addressing DTCs will help ensure a safer, more efficient driving experience with your Honda Civic. Please like and subscribe to the channel. See you next time.